Good morning, math scholars. Mrs. Harp here, coming at you with another Algebra 2 lesson. Today it's 4.6 day 2. We're solving logarithms. Make sure you hit the bell to subscribe and get notifications, and hit like and comment. And don't hit dislike. That's mean. Who's excited for the lesson? Woo! I have 20 subscribers. Wow. I'm halfway to 40, so thank all you guys that subscribed last week. Okay, so let's start off with what we're going to use for a few of the problems. If you have that log base 5 of x equals log base 5 of y, that can allow you to draw the conclusion that x equals y. So very similar to what we did last week with exponents. Cool. So let's look at our first example. So we've got log base 5 of 4x minus 7. And then we have log base 5 again of x plus 5. So raise your hand if you know what we can conclude. Lexi? Right. Basically that this pink stuff equals this pink stuff. And then can you guys take a second and solve the rest of that all by yourself? And then when you're ready to check, just look up and I'll have the answer up here. No, that gets a little different. I mean, it doesn't get harder than that. Solve the rest of this by yourself and look up when you're ready to check. Alright, thumbs up if you're looking up here and checking your work and you too got 4. Awesome. Okay. Everybody ready? 1 second. Okay. Alright. So now, this time we're in the world of the LNs. If LN equals 7x minus 4, and LN also equals 2x plus 11, since these two sides are equal, what conclusion can we come up with? Nick? Right, basically the pink stuff must equal the pink stuff. So same deal. Go ahead and you guys take it from here, solve it all by yourself, and look up when you're ready to check. Andrew, solve it all by yourself. On your paper. So, how did that one go? Thumbs up if you got x equals 3. All those scholars. Okay, the next one is a little different because we don't have two logarithms that are equal to each other and we don't have a conclusion that we can draw. But it's actually, I think, even easier to solve this. Do you guys have any ideas of how we can solve this? Spencer? Nope. Any other ideas? I'll give you a hint. We're going to do a quick left, right, center, and we're going to turn this into exponential form. So if you do a left, right, center, who's your base, who's your exponent, and who's your answer? Andrew? So same deal. Finish this one off all by yourself, get an answer, and look up when you're ready to check. It's not. Mm-mm. We have to do left, right, center just to kind of free up this stuff that's kind of trapped inside of a logarithm right now. You know what I mean? Let me pause this real quick. All right, our next one is a little bit harder. We have to actually utilize some of the properties of logarithms. So just a real quick recap on the properties. We learned last week the product property, and that was that adding and multiplying were friends. Do you remember that? Then we learned the quotient property. Who was friends with division? Subtraction. And then we learned the leapfrog property, and we had all those crazy frog noises. That's actually called the power property, where people can leapfrog from the exponent out front and vice versa. So my goal here is to get these condensed down into a single logarithm. Do you know what property we can use to do that? Not the leapfrog. Good guess. Who's friends with adding? Multiplying. So this would be the product rule. Yep. So we are going to actually be multiplying the 2x times the x minus 5. So I have to do a bit of distributing here. So I'm going to distribute that to that. Just a real quick reminder, who is my base since I can't see my base? Good. So 2x times x is 2x squared, and 2x times negative 5 is negative 10x. So I'm just going to warn you, this problem's a little bit long, so hopefully it's in space. Just because of all the squares. It's kind of yucky to solve when you have x squares. Nope, we're lucky this one's actually solved with factoring. Probably not, because that would be evil. I mean, if it's not factorable, then yes, you would. But both the ones we'll do today will be factorable. Hey, let's do a quick left, right, center to see what we're dealing with. Who would be your base? 10. Who would be your exponent? 2. And then who would be over on this side? All right, so let me remind you how you solve a quadratic like this. You get everything onto one side so that you're set equal to 0, and then you attempt to use factoring, either the old-fashioned method or the Fox method, and then if factoring will not work for you, then you're forced into the quadratic formula. So luckily that factoring will work for us, okay? What does 10 squared equal? So we're going to subtract this 100 over to this side so we can get everything set equal to 0. Make sure you're set equal to 0 before you try factoring and solving. All right, who are my factoring scholars back in whatever chapter that was? Chapter 3, Chapter 2, Chapter 1. Do you know how to do this? Well, we're not quite ready for that. Is this a box method problem? Yes. No, it's actually not. There's a common monomial. I can't believe nobody saw it. It's a 2, yeah. So let's factor that 2 out front, and that's going to make this problem a lot easier. So you pull your common 2, you divide every term by 2, so you have a negative 5x and a negative 50. And then this stuff here is what I used to call the old-fashioned method. I think that's what Nick was asking me about. You want to brainstorm numbers that can multiply to negative 50 that would add up to negative 5. So 50 and 1, 25 and 2, or 10 and 5. I like that idea a lot. 10 and 5. Now which one should be negative and which one should be positive? Negative 10, positive 5. Which means my solutions, do you remember how to do your solutions? It's the opposite of this and the opposite of this. So x equals 10 and x equals negative 5. Now, pause, let's catch up. That's a ton of work. Oh, are you tired? That's a lot for a Monday. One of these answers is actually extraneous. Yeah? Oh, left, right, center. 10 to the second power equals 2x squared minus 10x. So, let's talk about our answers. Earlier today, when we were going over homework, I mentioned that you cannot take the log or the ln of a negative number. It would cause an error or an imaginary solution. So if I would go to check my work, when I put this negative 5 right here, 2 times negative 5 would be negative 10, and I cannot take the log of a negative 10. So that means you trash can this answer. It's extraneous, and you only include this answer. So it's C. Yeah, that was a lot of work just to trash half your answers at the end, huh? Did you have any questions on what we did, though? All right, let me know when you're ready for the next one. Wait. Okay, just tell me when. Go ahead and jot this one down. I'm going to pause the video and have all the students try it on their own, and I'm actually going to call a student teacher up to solve it. So get ready to pause. All right, we had a student come up and teach this class. He did an awesome job, and he got x equals 38, so thank you very much. Here's our, let's do this one next. This is a word problem. We're going to do 2 word problems today. And our 2 word problems are going to be ones where we're investing money and trying to solve for how many years the money was in the account. So Tom wants to retire when he has $1 million in his account. If he's investing $20,000 in 2014 at 15% compounded monthly, how many years until he can retire, and what year will that be? All right. First of all, we need to choose the equation. What type of equation are we going to choose? The top one or the bottom one? The top, because he's compounding this money monthly, it's the top one, and you're going to put a 12 in front, okay? Everybody okay? The bottom one is only when it's continuously compounding. We have one more after this. So what's going to go in for y? The 1 million. So make sure you're using the correct amount of zeros when you're doing this in the calculator. That's 6 zeros. What's going to go in for a, the original investment? So that is 4 zeros. What's going to go in for R? How about N? And you put that 12 here as well. And then we don't know how many years it's going to be. So first of all, no, he's not going to be dead. But I wanted to give you a little heads up. This is not really a real life scenario, because most people don't just put a one-time investment in and then never touch the money. That's what's happening here. Most people keep adding 20,000 every year to that money. You know what I mean? No, it's not 15 every month. It's 15 per year compounded monthly. So it's 15% divided by 12. You know what I mean? So every single month, it is 0.0125. Yeah.
What's the advantage of having it like monthly instead of just annual?
I don't know. Just different banks do it different ways. Okay, so let's start. I would probably start yourself off by figuring out what number this is. I just did that on my calculator. It's 1.0125. Does anybody in here have an idea of how I could get my 20,000 over to join the 1 million? Divided over. Good. I'm glad no one said subtract. That was my other class's idea. Is that what Kylie said? Oh, okay, she's just giggling. That's what Lexi said? So 1 million divided by 20,000. Make sure you're using the right amount of zeros. It's easy to skip one. It's 50. All right. Anybody have an idea of what to do next? Right, we're going to use a logarithm to cancel this 1.01. So the logarithm we're going to use is a log with a base of 1.01. Like that. Okay, so that will cancel. But I have to do it on the left-hand side as well. So I'm doing a log with a base of 1.0125. So math up in your calculator to get the button. 1.0125 and a 50 in the big spot. That gives me a 314.91. And then all I have to do is divide by 12. So Tom is not going to be dead. All you guys thought Tom would be dead. It's going to take 26.2 years. And the question did ask what year is that. So 2014 plus 26 years would be about 2040, 2041.
That's not possible.
What? Why is that not possible?
No, because you're from missing $20,000. You can up so much that it's just all interest.
Alright, so we did get 26.2 years, and that's the year 2040. Your homework tonight is the back side of last night's worksheet. Okay, so it's just the back part. Hopefully you have it. If you lost it, let me know.